Hello everyone, today I will show you how to design building in Etabs by using BES file from AutoCAD. Now we have a architectural plan layout for the ground floor and for the first floor and for the second floor. And now we have to convert from the architectural plan to structural plan. We don't want to model this model directly in Etabs. Now we have to import it from the AutoCAD. It is very special for the complete project and complete shape of the building. You can easily import any shape from the AutoCAD directly to Etabs. So in the case for the regular building and regular grid, it very easily model in Etabs, but for the irregular and any special shape, we apply the same concept for this shape to complete shape. So you have to follow and let's check. Now we have to create the new grid line. Okay, new grid line, and we have to create the boundary for the slab in the polyline and the beam by using the line element, and for opening by using the polyline. So now we have to create new layer. I call it column, Etabs column, Etabs column. Now we select the new color, this one, and new other layer is called beam, Etabs beam, Etabs beam. We select other new color and we add other layer, new layer is called Etabs slab. We select other one and we add new layer, call it Etabs opening, and we add other new layer, call it Etabs grid line. Now we have Etabs slab, Etabs opening, Etabs beam, Etabs column, Etabs grid line, Etabs opening, and Etabs slab. Yes, it's complete. Now we have to select on Etabs or Etabs slab, Etabs slab. We have to create the slab boundary by using the polyline or by using the rectangular. Okay, now we have to start for the ground slab. Now I have to create the rectangular from here to here, or sometimes you can select it from the axis or center or column to other, but now in this case we have to model from the edge of column to the other edge of column. Okay, now you can see this one is the boundary for the Etabs slab, and for this boundary we have the very similarly, but we have other cantilever at the grid line C and the other cantilever at the grid line A. Now we have created the new boundary for the first floor, but the first floor is the same with the second floor. Okay, so I have to finish from this boundary to other boundary by using PL or polyline command. Select from here. Now we start from here to here to here to here. Okay, continue one by one. We will finish it soon. In the case we have to select for the boundary select only, not for the finishing element. Now we have to square from this one to this one. Okay, now I have to follow this boundary off. Now you have to create new boundary line by recommend PL and select from here to here to here to here, and let's continue. And you see here it is the boundary. Okay, let's start from here to here. And to other side. You have to draw from one edge to other edge. Okay. Center, so it's close the boundary. Okay, you have the other boundary for the first floor and the second floor is the same. Okay, now we have to draw the beam, or you can create for the grid line layer. So I have to select all the grid line here. Now you have to explode it. Okay, and select similar. Okay, select similar for the grid line, and for this one also select the similar, or you do not to do it twice. You have to do it for the grid line for the first floor. It's enough for export to Etabs. Now we have to change to Etabs grid line here. Okay, you see this layer is called Etabs grid line. Okay, now we have to draw beam element. Now let's start with the beam. Okay, Etabs beam, Etabs beam, and we press the command line. Okay, line, and we have to draw for the beam from here to here to here and to here. Okay, and for this one, press from here to here to here to here and to here. Enter. For the same, I had to copy it. Say all. Okay, like from here to here to discrete one to discrete line, and for the end it's the same here. Okay, it needs the same length, so we had to create other new from here to here to here and to here. Okay, enter. And now we have to create other new beam, so we have to start from here. Okay, let's draw it. Now I have to start from this one by using command line. Now we have to copy, or you can create other new. I want to copy it, or you can select the similar layer. Okay, and press CO, enter, and copy from here to here. Wow. Okay, now we have to draw the new here. Now we have to try to draw for the beam element, and you can copy it if you want. Okay, and for this one we have to enter. Okay, press C key and press the right click between 2 points. Okay, from here also between 2 points. Okay, perpendicular, finish, and we create a new one. Oh, the new one. Okay, C and press the right key, the right click, and between with 2 points. So let's check, is it the same or not. You can copy it to other one. Okay, copy, C O, enter, press from one here to other one. Okay, to other one. Just you have to correct in this part. extrude. Okay, okay, everything is fine now. Yes, we indicate to avoid the error you have to extrude from this one to this beam to avoid errors. Okay, sorry for model and delete and extrude it again. So now we have to check this beam. Okay, this beam we done. Yes, we do not yet complete it, so we have to copy it again. You have to copy this beam, and this beam to other grid line. Okay, now we have to check to make sure everything is fine. Okay, we have to complete for the beam, and now we have to define for the opening. Okay, the change from the beam layer to the Etabs opening. Now you see here it is the opening for the stair. Now I have to define by rectangular, but we do not define the opening from the boundary outside of the wall to the inside of the wall, or if we avoid the error, we have to define from the line of beam. Okay, to other side of beam. Okay, in the case we have to define here, and now we have to copy from this one to other one. Okay, to other one, it's the same. Okay, now let's check the boundary opening is okay or not. Okay, so to avoid error or load transfer to a beam, so you have to define the opening to the beam. So this is the way we have to correct the load transfer to the beam. Now we have the beam and slab and the opening for the slab. So the opening we can copy from the top to the bottom. Now we has not to define at the ground slab, but we have to define it in the first floor. Now we have to start select the Etabs layer and move it to the other side. Okay, okay, for the opening it's the same. Okay, CO and copy it. Okay, so we have the boundary at the ground slab, and we have the boundary for the first slab. Okay, so it is the opening. You can check here, it is beam, and this one is the boundary of slab. Okay, now we have to define for the column. To avoid the error from the architectural plan that block the column, we have to create a new column. Our column is the rectangular section 20 multiplied 30 centimeter. Now we have to create it from the new, or you can copy from this one to your model, but I have to avoid the error. I have to create new one. Okay, now let's create the new one. Rectangular depth 200 300. Okay, so you have to change it to the column layer, Etabs column. Okay, and add the property, match property. Now I have to copy it to the grid line. Okay, 1 2 3 4 5 6 7 8. Okay, we had at the grid line, not at here. Okay, now has to copy it to the other grid line. Select the similar, copy. Okay, so we have to complete the modeling in AutoCAD. Now we check here, we have the beam, but in this we don't have the beam yet. So I want to create the beam like the slab boundary. So you can copy this boundary to other side and explode it and delete it. And I want to create the beam like this boundary, so you have to match the property from the beam to this beam. Okay, check it. If the attached slab not right, we have to match it again from the beam. Okay, now move it again, to relocation. Okay, so you have slab boundary and beam boundary. Okay, that's great. And for the ground slab, I don't want to model it again because we have already completed the model at the top slab, at the first slab. Now you have to check your model, it's good. Okay, no other error. And for this beam, we have to add this one beam to support at the opening at the stair. Now we have to create new Etabs beam. Okay, let's start from the alley. Okay, the line, copy. So if you want to add other beam support there, you have to create here. In the case I don't want to model stair directly in a tab, to avoid any wasting time, we can quick modeling in a tab. So we divide a load to apply at this beam. To accurate, you have to apply and modeling the tab, the stair in the tab directly, but in the case I don't want to model stair. Now we have to check model. Okay, it's good. I want to create and copy it to the other new file. We have to create a new file, and now I copy it and pass it. Okay, it's far away from the original location. Oh, no. I want to copy these two. Control C. Control V. Okay, Control V. Now we have to move. Move this. Move this left to other direction. Okay. So we have the ground slab, and this one for the first floor. Okay. Now I want to move this to the original location. Okay, now we relocation this at 0, 0. It is easy to us to make grid in Etabs. So now we have to check the unit, UN enter. Unit in, now you have to select the millimeter. Okay, and OK, check. Okay, the default setting unit is millimeter. It's grid. Okay, now we have to show up this file. I want to show up is the link house to Etabs model, and we have to save as this file to DES file in the version 2010. Okay, link house, we can call it link house Etabs for modeling. You can put any name as you want. Okay, now you have to close this one. I don't want to save it again because we had to save it already. Now we have to open the Etabs model, Etabs file. In the Etabs, you can using a new model and open your existing model. In this case, we had to select on new model. And you can use it from your model, your existing model, to import the material, to import the cross section. In the case you don't want to create it again. Now in the case I have to define everything from from the beginner level. Now we have to start it from the new section, the new material. Now we have to select the unique display is the metric as a unique style section. Okay, you can select your code or your section. Now the concrete design is the zero code. Okay, and for this grid is not important because we have to import our grid line from the tab from the DEF file. Now for the story, it's really important for us, so we have to define it as the 3. So you have to edit the story from 1 to 1. Okay, let's check with the from this floor to other floor. At the bottom floor is the 4 meter, and for other one is 4.2. And for this one is also 4.2, and the master 3 we use the same as the story 3. Okay, and we can change, but in the case we have to select on the blank. Okay. You see here we have to import DES file of the architectural plan and select your location. Okay, our unit in AutoCAD file is millimeter. Okay, it's correct. Now we have to import this DEF file to the story 3. Okay, you see here it is our original location that we move in AutoCAD. Now we have to convert this file to structural model. Now select on tab display, plan view, architectural layer. You see here there are a lot of layers, so I want to deselect all. I want to open for the Etabs layer only. Okay, so now you have to convert from the DES to structural element. Here at tab grid line, you can right click and add grid line. See here the grid line create automatically. Now you have to create a tab slab. Now I want to create a new tab. Okay, you can slab 1. You can change it next time. Now I have to define it as slab 1. Add tab slab, right click, add area object. Okay, you see here it is the boundary for the top slab, and this one is the boundary at the bottom slab. Okay, and for the column we use the same. If you have create the section already, you can assign it, but in the case I do not yet create new section. Now we have to select it the column. Okay, and right click at the tab column and add column object. Okay, we can add for the all story. Okay, you see here the column automatically generated. And for other one, for the Etabs beam, okay, Etabs beam we use the same, but we change it to the column beam, conscript beam. Okay, Etabs beam. Okay, add beam object. You see here, all beam automatically generated. Betting software generate beam. Okay, okay, complete. And now we have to seal there. Seal. Okay, I seal it in a tab. Okay, now we have to move this lab to the bottom. Okay, now select this lab and select the edit, replicate a story, add to the base. Okay, the base, and select delete original object. You see here, in case you have to make data stem column, you can input other floor. So now we have to select this one, okay, this one, the boundary for the top slab, and copy it to the other story, edit, replicate story 2 1, apply. Okay, but if you don't want to delete it from the original, you have to keep it. Now let's redo it again, and previous select, you click here, and you can select new one, edit, replicate story, and untick delete original. Okay, okay, now we have to complete the 3D with the seal it. Now in the case I want to create the stem column, you can change it to 3 meter. Okay, 3.2, and the story one is the 1 meter in the stem column. Okay, okay, for the stem column, and we had to delete slab at this level, edit and delete, and you can check everything is fine now. Okay, it's good right now. Okay, now we have to create opening. Okay, opening for the stair. Control and for the tab opening, and select the slab and change it to the opening. Okay, right click and a tab opening, add array object. Okay, you see here the opening is generated. Now we have to select X, select the opening here, 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 and copy it to the other floor. Edit, replicate it. I don't want to, if you don't want to open it, you can delete it. Okay, and delete it into story 3, 2, apply. Okay, we have opening at this floor level. Okay, save. And for the ground floor, if we don't want to keep it as the same as the first floor, we have to delete it and take it as one story. Delete. Delete. Sorry that I delete the previous slab. Now we have to create new slab. Okay, it's called the slab 1. Just activity easy. Okay, you can check it in the 3D model. Yes, it's very nice. And save. You have to check your model has any error or not. Select all. You see here, sometimes take long time to model in the file to Etabs, but for the complete project, you will take advantage from it. So for the complete shape, complete building from one floor to other floor, this option is pretty good to help us to model link for the complete and to avoid any error. You cannot model the complete shape directly in Etabs, but you have to use the DSF file to help you to model the complete shape. Okay, now that everything is fine, no other error. We have to change. Okay, we have to change the slab section from 1 to 120. Okay, we keep everything in the zero code. We have to add a European concrete. Okay, 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 okay. Now select here and click. You see slab is slab 1, not to change the name, so we have to change the name to slab 12 cm. Okay, now you have to check it again. Okay, it changed. And for the column, we have to define the new column section. Okay, add new. Okay, add new concrete. we have to define it the C 20 multiplied 30 centimeter, and the concrete do the same for slab and column. And here we correct the dimension. Okay, now I don't use a section modifier. And for the rebar, we have to add new material from the China steel rebar. Okay, GB, we have GB 500 and GB 4. Now this strength in it is unavailable in my country. Now I have to change to other, but you can create you want, but I don't want to create it. I want to use it automatically from the default. Okay, for the main rebar, you can check the strength. 400 is good, and other one is for the C rebar. Okay, I call it the C rebar. For shear, you can check it 240. Okay, it's good. Okay, now we change it to the main rebar, we change it to the C rebar. And for the reinforcement to be designed to be checked, if you want to be checked, you can input the rear bar diameter and rear bar arrangement are the same in the plan, but in the case we have to design it, we don't care too much about this arrangement. Okay, in the case you have to check it, you have to input the correct diameter, the correct rebar shear. Okay, now in the case I don't want to use the correct, because we have to design it. Okay, the column is rectangular, you the tie, in the circular you have the tie and the spiral. Okay, select OK. Strength of grid is OK. Now we have to select object type column. We have to assign it to frame section to 20 30. Okay, now we have to define other section for the beam. We can add copy from here, or we can create a new one. I want to create copy, but it's called it beam B 20 multiplied to 40 centimeter. And for the strength concrete, we keep it the same, but you can issue as you want. It's 400, but we change it from the column to the beam, and we use the same longitudinal and confinement bar for the shear bar. This is the rebar cover to the center gravity or rebar. Okay, we have to select object type beam, select. I have to assign it quickly. I don't want to create other different section. Okay, everything is fine now. I had to assign load to each floor. Now you have to select object type. I select on the floor. I want to assign cell uniform, and the load for the concrete tile with the mortar. The thickness is 5 centimeter, so it's equal the density 22 multiply 0.05, the thickness of the mortar and the concrete tile. Okay, the floor tile. Okay, for the floor tile, and enter. You see 1.1 kilonewton per square meter. Okay, apply. Okay, you see here 1.1, and for the light load, I apply it. We have to select the previous leg and apply it 1.5 for the minimum load. For the residential building in the general code, we have to follow the regular and apply. And okay, we have to select it and check. Now I have to seal it again. Seal. You can select and story 4 for the rows. We have to reduce the light load. Right click, and you see the section property. Diaphragm not just assigned. You can assign diaphragm for the apply with load, and section modifier not modify. And for load here, the load pattern, this load and load pattern for light load, you can change it directly from here. Now I want to change it to only 1 kilonewton for the top roof. Okay, you can change directly from here. Okay, it's a good option. You have to check it again, it's correct or not. Okay, you see here 1.1 for the load and 1 for the light load. And for the floor, it's the same concept. You can change it directly by input and correct value for the load. Okay, select the 3D model. Okay, now I want to modify for the thickness of the slab to the correct section. You can assign it according to the ACI code, because the individual code not has implement or talk detail about this point. We have to follow for the ACI to apply in the correct section. Now I have to apply it for the for the slab only. We have to clear sign and select and define section slab. We change the section modifier for the bending to 0.35 for the ultimate design. Okay, and you can apply it for the column, for the beam, it's the same, but in the case I want only apply for the slab. Okay, so you have to change the master story from here to here to the story 3. I want to apply load at story 3. Okay, refresh, view the similar story. And we use the story 3. Now I want to apply the brick. Okay, the brick, the outside is the brick 20 centimeter. Now we have to select here, to select here, to select here, to select here. Okay, this one, add this one, add this one, add this one, add this one, and select the similar story and select assigned frame distributed. Is the load for the brick wall. and the thickness of wall is equal to 0.2, and for the density of the wall is 16 kilonewton per cubic meter, and for the height of walls is the 3.2 minus the height of the beam is 0.4. 3.2 minus 0.4. Enter. Okay, it is the brick wall. Okay, apply and apply. Okay, and for other beam is we had the same, we can apply it the same. Okay, assign, uniform, distributed. Okay, you can see here, apply. And for the not the same, we can reduce it. No, sorry, select. Okay, select. We have assign, clear assign, select, and select the beam, this beam, and we have only for the thickness of wall is 10 centimeter. Now we have to divide it by 2. Okay, apply it. Okay, seal this model. We have to view it in the 3D. Okay, everything is great now. You see here the load is applied also in the column. Now we don't want to apply it in the column. Now we have to delete it from the column. I don't want so the beam or floor and or opening. Okay, and you have to select object type for the column, select and delete, assign and delete. Now we have to delete the load. We don't want to apply the load of the wall directly to the column. Now we have to show all object, open, beam, floor, opening. Okay, we can extrude it. Okay, you see it is the full 3D model of our structure, and we have to check the load applied is correct or not. The load, okay, you have to check from floor to floor, and at the top is no other load. Okay, it's correct. And for the load on the slab, we have to check here. Okay, 1.1, 1.1, 1.1 is the same, and for the load, for the line load is not the same. Okay, and this wall is the same, 1.5, but at the top is only 1. Okay, it's correct. Don't forget to seal your model. Now we have to assign soil spring to the bottom slab. For the SI unit, KS ks is equal to 40 multiply as 2.5 satisfactor and multiply by allowable soil bearing capacity is equal to 100 kilonewton per square meter. In the case, now we have to get the value and we have to copy and pass it and copy it to a tab. Now we have to select the ground floor, assign sales area spring, have to modify, add new, and we have to soil spring, and we have to change this value and we have to select the compression only. Okay, apply, okay. So in the case we apply the soil spring, the load transfer at the top of the step will be transferred directly to the soil spring to reduce any load distributed to the column. So you have to reduce the more load from the top of the ground slab to the foundation. Okay, you can check and modify the case as you want, and you can to compare in case you have to assign to soil spring and other case you do not assign soil spring. What is the difference between the total load and the survey load? You can observe by yourself. Okay, but in the case we had to assign soil spring to resist the same load at the bottom and to enhance our stem column. Okay, now we have to complete the model. Okay, everything is fine. In the case we do not apply any horizontal load, wind load, we apply only the gravity load. Okay, now we have to analyze this. And for the load at the load of stair we do not apply. For the realistic you can apply load of stair at the opening, beam support opening, or you can model stair directly at here. Now you have to check what is the bonding area. Now info bonding, no. Okay, now we have to check the model animation. You see here what is error here. Okay, delete it. Okay, and check your model again. Everything is fine, and now we have to run it again. Now you have to check the animation, what is wrong. clean. And for the mesh option, you can change the mesh as you want. You can select slab. You can assign share. Okay. Mesh option, we have to define it only 500 for the maximum. And we have to assign share auto edge constraint. Okay. We do the same, assign frame. No, we do not have to assign for the frame. Okay. Now we have to complete it and run it again. You can check load case. It load in the new case model for dynamic, and the load combination. We can add new load combination manually by input one by one, but you can also generate it automatically from here. In a tab, although you do not define the load combination, when you design, the load combination will be automatically generated in the design state. But in the case I had to define it automatically. We had to convert it to user combination. You can edit it. Okay. Now we have select on the concrete frame. Okay, you see here, when you tick the option, you can change the you can change this name. I call it SLS, and I add the line load also one, and this one I had to change it to ULS, the ultimate load. Okay, and now we have to run it again. Okay, you have to check your model by observe the animation. Okay. Now it's fine. Now we have to check for the moment, the ultimate. And you can use MC3 or you can use the influence moment in the same meaning. Okay, you show the value. Okay, you can see here the maximum moment at here. Is minus 127.22 kilonewton meter, and the shear is the minus 90 kilonewton. Okay, you can check for the shear to 2. Okay, you can check for the moment to 2. No, you can check for torsion as a lateral torsion. Okay, now you can check for the shore compression at the ultimate limit state. Okay, for the maximum is about 100 about okay 100 ton. Okay, it's about 100 ton for the actual compression. So for using the column 220 multiply 30 centimeter it says for the case. Now we have to check for the reaction. Planned best okay, we want to show only for the vertical reaction, acid reaction. Now you can change the font bigger by using graphic reference. I want to show it bigger. Okay, you can see it clearly. Okay, this is the service load, SLS load on each column or on each pie cap. You can take the reaction to design for the foundation. Now we have to check in the display so table and check for the joint output reaction for the design reaction and select load combination or locate you have to display. I have to display only for this load. You can select only this load. And for combination I want to select only the SLS. Okay, you check here the load types, the combination. You have to show only for the combination. Okay, and the story we have to assign for the best story only. You can check here at the unique name 49. Okay, 49 here, and the total vertical reaction is here. It's the same, 306.47, and for other one the unique name 53. You can check here, so 53 okay, here 53 is the same and 57 is the same. Okay, it's the same. Now we have to export here to Excel. Okay, now we have the Excel sheet. I want to focus only for the vertical reaction. We have to sum it. We take it as the total asset. You see here the unique is the kilonewton. Okay, kilonewton. Now we have to estimate the load distributed on its pie cap or on its base column or on its stem column without any modeling. So we have to to adjust from the existing bidding to estimate the new future bidding. By don't know the actual load, so we can estimate for the future by using this method. You have to check and follow with my method. Now we have the total, and we check the here the total area at the base. Okay, total area at the base. Okay, has to copy it and multiply it by 10 power 6. We convert it from the millimeter to meter to square meter, so you have to divide the area. Okay, so in this case we have to check it is the total reaction export from the Etabs software. Now we have to calculate the total reaction and the vertical reaction and divide it with the area of the floor and divide it with the number of floor. Okay, we have to divide it with the number of floor. Our concrete floor, we have the 4 concrete floor, 1 2 3 4, include the rows. Okay, include the rows, is equal to 10 kilonewton, or is equal to 1 ton per square meter. Okay, we have this value to estimate for the now you see here we have the total reaction from all the column. We sum it, and this is the floor area at the base. We assume it due the base area only, and here it is the average reaction of column. We take it is equal 1 ton per square meter, and for this area we have the 5 multiplied with 4.5. okay, we take the value 5 multiplied with 4.5. okay, we take this zone to estimate the circuit load. okay, 5 multiplied with 4.5. okay, let's check. This area is 22.5, and now we want to estimate for the circuit load on each column. Now you have to use this multiply with 1 ton. Yes, you use this area. okay, this area multiply with the average column reaction and multiply with the number story. okay, number story is 3 story. okay, not the concrete floor. First this one we divide with the concrete floor. okay, is the 4. You can count it in the tab. 1 2 we can count it in a tab. 1 2 3 4. Okay, it's 4. It's 4 floor. It's 4 floor. Okay, 1 2 3 4. And but for this we do not multiply with 4. We multiply with only 3. Okay, 1 2 3. Okay, because I want to use it as a town. Okay, also you can use the formula multiply with this one and multiply with the 3. Okay, yes, this value is from here to here because this value we round it to 1,000 per square meter, but it is the actual value, so our reaction is around here. Now we have to check at the real model what is we have to check for the best. Okay, in this location you see here, because we do not consider the stair reaction, but if we put the stair and load from stair, we will get the result. It's the very similar result with this one. So for the average for the one column is around 715 kilonewton per column. Okay, but in the case because we do not include the staircase. Okay, if you include staircase, the value is around here. So for the estimate for the foundation, you can take the range from the reaction SLS. You can use the column area as the square meter, multiply with the average column reaction is 1,000 to 1.3,000. So you will get the average reaction and multiply with the story. Okay, the 2 story, 3 story you can add here. Indicates the column area. The column area is a 5 multiplied with 4.5. Okay, 5 multiplied with 4.5. Okay, in this unit. And estimate for foundation reaction, you can estimate from here, multiply 1,000 per square meter. Okay, we have from the value is around 1 or to 1.3,000 per square meter, and multiply with the story. Indicate our story is 3 story. If we include the ground floor, we call 1 story, 2 story and 3 story. So we have to multiply it with the 3, and this one is the area of the column, and this one is the average load per column. So you will get the estimate load for the circuit load to design for the foundation from here. Okay, this load is around 71,000 per column. Okay, you can take the value to estimate for your foundation load. Okay, okay, it's called the column area. Here the column area multiply with the average column reaction, or the average column load is around 1 ton to 1.3 ton per square meter for the simple story, and multiply with n story. Okay, n story here is 1 to 3, so you will get the reaction for the surface. Okay, okay, for the estimate here you can see the value is around here. Okay, okay, now we have to continue and design for the column slab. Design concrete, and we have to check because we use. Okay, it's correct, and design concrete, start. Okay, everything is fine now. We have to check for the column. Okay, use the minimum rebar in the column. You can see here 600. Okay, in the 600, 7, 8, you can calculate the rebar. Six hundred, 700, 840. The unit in millimeter is millimeter square, and we input the 8, 14. We use diameter about is 16, so we use 4 dB 16 diameter or the form bar for the column. Okay, now we have to check for the beam. And this one, okay, for the design moment, for the long short thermal, and for the shear, it's okay. We have to input the top rebar at the location 0.1 from the support is 1290 millimeter square. So you have to input the value. So if you use 16 diameter, you have to use 7 dB. Now I have to use it 20 diameter. You use 5 dB. Okay, for this section. And you can also display it as the beam capacity ratio. Okay, can I show? Yes, you can check here. We apply for the same load and the story 1, story 2. The reinforcement in the column in the beam is bigger than at the ground beam because we had to assign the soil spring, so the load has been distributed directly from the ground slab to the soil spring. Now you have to check the soil spring can support this load or not. Okay, it's around here, around 9 kilonewton per square meter. Okay, it says it's compared with our input is 10. Okay, it's 10 kilonewton per square meter. Yes, it says. Okay, you can see here it's around 8.5. Okay, 8.5. Okay, now we have to check for the column. We will start check from here. The story 1, column 20 multiplied with 30. The column name is C9, and we had to detail. Okay, check for the detail. Here the section property, the material property. Okay, we use the concrete cylinder 30 megapascal, and here the design load apply at our column is 917.42 59 kilonewton, and other for the design moment. Okay, minimum moment for centricity and rebar here use the minimum rebar percentage is 1%, and the axial and basal moment vector you can check here, and it is the compression capacity for the concrete, not include the rebar. So you can check here the alpha cc, the safety factor for the concrete multiplied with the section of column multiplied with the design strength for the concrete. Now we have to verify it is the same or not, and the alpha for the default for national net is equal 1. For the BS, for the British standard, or for the unique for the United Kingdom we use only 0.85, but in the case we use the default national net, it apply 1 and multiply with our section 200, multiply with 300, and multiply with our concrete is 30, and divide it, the safety factor is 1.5 for the concrete. So you got here divide by 1000 to convert the unit. So you will get the same, is the kilonewton. So here how this will calculated. Okay, the safety factor for the national edge from national edge for the concrete multiply with the cross section and multiply with the design strength of concrete. Design strength of concrete, you have to use the concrete strength divide with the safety of 1.5. Okay, so you will get the result is the same. What is meaning? When you use this compression ratio, you have to divide this with is 1. So you can see it's 0.765. okay, here 0.75, and the design ratio is okay. You can check detail by using Matcat or by using Excel set. Okay. Now we have to design for the concrete slab. You can check the code. Okay, the default digital code, and we had to select the low combination, and you had to select the design story. You can only design for the story 1, story 2, or you can select all. No, it has a multi-story. It's over 100 stories, so you don't want to run it over all the story. You want to minimize the running time, you have to select only one story. In this case, I have to define and design only story 3. Okay, and design concrete slab. You have start design. Now I have to display for the story 3 only. You can see here. Okay, calculate for the story 3 only, for the story not calculated. Okay, 1, 2, 3. Okay, here. So we have to review on this floor here. Okay, you can see here it is the maximum moment at the local axis. We have to solve for the ultimate limit state and resultant for the unbound one. Okay, unbound one here from this section you can see, and the beam is 6.2 at the column is around here, and for the M22 for the y-axis. Okay, you can see here maximum at here. Okay, and one is moment at x-axis. Okay, from here to here, x-axis, you can see the maximum at here, and M22 for the y-axis, M11 for the x-axis. Okay, x-axis, M22, y-axis here to here. Okay, you can check. Now we have to design it from the finite element. I don't want to design it from the strip. I have to design it from the visual design. You can check it based on finite element methods, and you can check in for minimal reinforcement. Okay, to follow the code, you have to select the option, and now we have to select on top to check the reinforcement ratio of reinforcement in the required reinforcement millimeter per square millimeter per meter. Okay, in the concrete millimeter per meter, as you can see here. Okay, you can check here, and bottom bottom one in each direction. Okay, you can check here. Top two in y direction, you can check here, and bottom in y direction, you can check here. Now I want to apply the reinforced diameter 10 and spacing is 200 for the top. So you can check it. Okay, it is says. And for the bottom, it is says. And for the top, okay, the top we have to add body bar at the column. And for the other bottom, so it is said to use db 10 f 200 millimeter for both top and bottom direction. Okay, so you can use this db 10 f 20 millimeter for both top and slab, and but the top we had to add the top of the column, but in the case we has not to add it. It is says. Okay, it is says now. So you can okay, we can finish this tutorial. It is the summary and quick tutorial. You don't have to detail about the design report, but in actually you have to do the design report for the owner. Thank you for your watching. Thank you.